Let's say you're going to the store and you have $10 to spend. You go to the store and you have $10 to spend, and you need to buy some bread and you need to buy donuts. Or you know what, let's change it. If we're going to go to the store and we're going to buy donuts, then we're going to buy donuts and kolaches. Donuts are normally cheap, kolaches are normally expensive. So we have $10 to spend, and we're going to spend it on $1.50 kolaches or 50-cent donuts. If we write this as an equation and we change it to all be dollars, then our equation would say 0.50 times donuts plus $1.50 times kolaches will be equal to our limit of $10. If we wanted to find out what our graph would look like, then we could start with the intercepts. 50 cents for a donut, and if you bought all donuts, that'll be 0.50, and I'm going to shorten donuts to just be D, plus 1.5, and if you bought all donuts and 0 kolaches, you would be spending all $10 on your donuts. And if you're spending all $10 on your donuts, that's 0.5D equals 10. Let's divide by 0.5, divide by 0.5. The total number of donuts you can buy is 10 divided by half. 10 divided by 1/2. If we're cutting 10 into pieces that are half the size of a normal piece, then we're actually going to have 20 as our answer. The intercept for donuts is 20. You can spend all of your money and get 20 donuts and 0 kolaches. So as an ordered pair, that would be 20, 0. If we spent all our money on kolaches, that would be 0.50 times 0 plus 1.5, 1.50 times k equals 10. So really we just have 1.5 k equals 10. And if we divide by 1.5, 10 divided by 1.5, since I don't have a calculator, let me just do a fraction. I think it's going to be 7.5, but that's going to be 20 over 3. So it's 6.6. 6 2/3. Unless you're like a regular at the store, you're probably not going to be able to buy that last 2/3 of a kolache unless you dig it out of the trash. And I hope you're not digging for kolaches out of the trash. But let's just imagine that this really could happen. Let's say you knew the person and he said, I'll sell you 2/3 of a kolache. Then that point would be 0 donuts, 6 2/3 kolaches. So we have 1 point, 20, 0, 1 point, 6 2/3 with 0 for x. So when we make this graph, we have kolaches on the y-axis, donuts on the x, and we could buy 20 donuts with 0 kolaches, or we could buy 0 donuts and 6 2/3 of a kolache if we spent all of our money. And that would be the graph. So we could split some numbers. Here would be 10, 0, This would be 3 1/3. Any point on this line would be a combination of donuts and kolaches. But what you would notice is if you buy more donuts, then you're going to have to buy less kolaches. As your donuts increase, your kolaches that you're buying decreases. You could either invest all your money buying kolaches, or you could do some mixture. But if you do a mixture, then the more donuts you buy, the less kolaches you buy. And that could be interpreted to go the other way. If you spent less money on donuts, as you spend less on donuts, you will spend more on kolaches. And donuts and kolaches aren't depending on each other. So that's why I said before, it's not really about inputs and outputs. It's that X and Y are related to each other, and that relation can make this equation. As a 100% math interpretation, this line has a negative slope, but as a Mr. Ramirez interpretation, if you're buying donuts or kolaches, you did something good that day.